Also, since it is a partial order set, A less than is equal to A, so it implies what? It implies that A is less than is equal to B, A is less than is equal to A. Means what? A is greatest, A is lower bound of A and B. Because see, A is less than or equal to B, A is less than or equal to A, so A is lower bound of A and B. It's clear? Now basically what we have to prove, we have to prove the greatest lower bound of A and B is what? A. This we have to prove. So let D is greatest lower bound of A and B. Of course, then just assume that D is the greatest lower bound of A and B, and finally we prove that D is equal to A. D is none but A, correct? Because there can't be two greater lower bounds. So then D is being lower bound, D is less than or equal to A and D is less than or equal to B, correct? Also, since D is greatest lower bound, therefore D is less than or equal to, still A is less than or equal to B. See, because we already proved that A is lower bound of A and B, correct? So A is the lower bound of A and B, and D is greatest lower bound. So it means what? A is less than or equal to D. D is greatest. So D less than or equal to A and A less than or equal to D implies what? D is equal to A. That is, implies that D is what? Greatest lower bound, and greatest lower bound is of course unique. So we have proved that greatest lower bound is none but an A, element A, correct? So finally we move to the last result of our unit 1, and very important result. Important does not means that possibility of it occurrence in the examination paper will be there. It means that it is important, it's good result, it may have good applications, it may have good use. So proposition 1.3.2, let E be, this is on page number 14. Visual simulatus, then E is commutative, semigroup. Consisting entirely of idempotents, and for every A belongs to E, A less than equal to B implies A. So it has also one more part, the converse part you can say, but I will write afterwards. First I will prove this, after proving this I will write the next part of this. Okay. So try to prove this. Try to understand this. First thing is to understand the problem. Let E be a lower semilattice. So it is given that it is lower semilattice. What is the meaning of lower semilattice? Lower semilattice means that for every AB belongs to E, greatest lower bound exists, isn't it? So it means that is the meet of A and B exists for every AB belongs to E. This you have, correct? Now what we have to prove, we have A meet B belongs to E for every AB belongs to E. E is what? E is semilattice. Being semilattice, of course, it's the partial orbital set. Now, what we have to prove? What is our claim? We have to prove that it is commutative semigroup consisting entirely of idempotents. Commutative semigroup consisting entirely of idempotents. That is, we have to prove. What is our claim? We have to prove that see, this works as what? Basically, this works as binary operation, isn't it? Because see what they are saying. They are saying that E forms a semigroup with respect to this operation. E forms a semigroup with respect to this operation. Of course, it is closed. So E is closed with respect to this operation, as E is lower semi-lattice, correct? So A is closed with respect to this. Now what else we have to prove? We have to prove, now we show that. Now we show that like this. If we are able to show this associative law, then with respect to this operation, E forms a semigroup. After proving semigroup, we prove that it is commutative, and also every element is idempotent. That is, A join A is what? Again A, correct? So let's see how we prove. We prove that this one is what? This one will be the greatest lower bound. Let first assume that let D is greatest lower bound. Just I am writing GLB. GLB means greatest lower bound of A, B, and C. Then what we have? We have D less than equal to A. We have D less than equal to A as well as B as well as C. Also, it implies that. It implies this. And also it implies that D is less than is equal to see, D is the greatest lower bound of A and B. That is, it means D is the lower bound of A, B, C. It means that D is less than is equal to A, D is less than equal to B, D is less than is equal to C. Correct? Now, also we can just write like this. See, A join B, A meet B, that is greatest lower bound of A and B, will be greater than D. Why? Because this is the greatest lower bound of A and B. So of course it will be greater than D. So D is less than equal to A, you know. So just yeah, of course, this is being greatest lower bound, it is greater than equal to D, and also D is less than equal to C, because D is being greatest lower bound, it is also a lower bound, of course. So D will be less than C. No problem. So now from here you can just write D is less than is equal to like this, because this is one element and this is another element, and when D is less than equal to both elements, of course it will be less than equal to the greatest lower bound of these two elements, because it is the greatest lower bound. Being greatest lower bound, it will be greater than D. So D is less than equal to this, correct? Now Now, well, you can see D is less than or equal to this. Now, what you have to prove? Also, you see A meet B. Is less than or equal to A as well as B. Correct? And C is less than is equal to C, of course, because this is what? This is the lower bound, greatest lower bound is lower bound, so it will be less than or equal to A and B and this is less than C. So which implies that A meet B, if you take just you take just meet of this, it will be what? It will be the greatest lower bound. It is lower bound, so it is also less than or equal to. Well, it will be less than or equal to, of course, A, B, and C all. Because A meet B. A meet B is what? It is. Of course, it is the lower bound. Being greatest lower bound, it is the lower bound. Once it is the lower bound, and A meet B, you just consider this as an element. This as an element. Okay. So now, well, you can just see like this. It will be just like this, right? And now it is this and this. Now if you can understand this, as well as A join B meet C, and see these inequalities are very trivial. These are trivial. That A meet B meet C is less than or equal to C. Why? Because this is the lower bound, and lower bound is what? It is less than or equal to C. Correct? So now you see this one is the lower bound of finally. It implies that A meet B meet C is lower bound of A, B, C. This is the lower bound of A, B, C because it is less than or equal to A as well as B as well as C. And being lower bound of this, it is the lower bound of this. So it means that, and D is what? D is the greatest lower bound. So you just write since D is greatest lower bound of A, B, C, therefore you have A, B meet C is less than or equal to D. So now you just combine these two inequalities, 1 and 2. D less than or equal to this, and A meet B meet C less than or equal to D. What 1 and 2 implies in a partial ordered set? Of course, 1 and 2 implies that D is equal to A meet B meet C. Correct? So, similarly, we can show that. Like this. Now, since the greatest lower bound is unique, correct? Therefore, A meet B meet C is equal to A meet B meet C. Therefore, E with this is semigroup. Correct? So semigroup. Now the remaining portion is trivial. That is trivially A A meet B is equal to B meet A, because as greatest lower bound of A and B is what? Unique. It's not different. Greatest lower bound of A and B of your greatest lower bound of A and B of B on A is the same and it's unique. So both will be equal. It can't be different. Also, A meet A, what it will come? If you talk about, of course, it will A meet A. It will come what else? A. This we have proved already. A less than or equal to B implies it implies. So from this it follows A less than B implies it implies A meet B is equal to A. So A less than or equal to A is a particular case. Of course, it implies A meet A is equal to A. Of course. So in this way, this part is proved. This we have already proved. This fact, right? So you have to paste that fact here in order to prove the first part of the proposition of fact 3. So now we will prove the converse part, and after proving converse part, your unit 1 will be finished. So we are reaching to the end of this lecture. Converse part is that conversely, suppose this is a commutative semigroup. Why am I important? Is commutative semigroup of commutative semigroup of importance. Generation this on E defined by A less than B and only if AB is equal to A is a partial order on E. The partial order on E with respect to which E is a lower semi-lattice. And E the meet of A and B is the product AB. So, see what is given. Suppose that E with respect to multiplication is a commutative semigroup of ideal potentials, isn't it? So what we have it is given this. This is what commutative semigroup, correct? That is AB is equal to BA. For every AB belongs to E, every A belongs to this. So all these things we have, correct? Now what we have to prove? The relation is defined like this. That A less than B is implies AB is equal to A. So first we have to verify that this relation is partial order on E. Correct. First thing we have to do. What is the relation defined like this? This is defined like this. AB is equal to A. So of course it is true. See, well, you can see that A square is equal to A. What does it imply? It implies that A is related to A itself. That is, this relation is what? Reflexive. So A square equal to A, we have, of course it implies A is equal to A, so it's reflexive. Now well, you can see that relation is also, if you take let A less than B and B less than A, then what do you have? Then you have AB is equal to A and BA is equal to B. Correct. Now where you can see that A is equal to AB and AB and B are both equal because E is what? Commutative semigroup. So AB equal to BA is equal to B. Since E is what? Commutative semigroup. So therefore this is what? Anti-symmetric. So relation is anti-symmetric. Now what we have to see? We have to see that relation is transitive or not. Now let's see. Relation is transitive or not. Now if you assume let A less than B and B less than C, then what you have? Then you have then AB is equal to A and BC is equal to B. Now just calculate AC. What you can write A as A, B, C. Since it is semigroup, it is associative, of course, so it can be written as BC. Now BC can be written as like AB. So AB will be what? A. So AC is A. AC is equal to A. What does it imply? It implies A less than C. It implies that star is transitive. Transitive, what does it mean? It implies that this is partial order on E. Because relation is reflexive, anti-symmetric and transitive. So finally relation will be what? Partial order. So in this way relation is proved. Partial order. Now what else is remaining? Now just it is remaining to prove that with respect to this relation forms lower similators. Lower similators means you have to show that the meet of A and B exist. Meet of A and B. Since it is a what you have to show? We have already proved that it is lower similar.